I'm doing this video to help you find the average rate of change when given a function. So say find the average rate of change of this g of x equation on this interval. So when we originally started out doing problems that were given a graph, they would say, hey, find the average rate of change. And the rate of change is the slope of that graph. And as you can see, the rate of change is really, really steep, and then it gets less steep. And then as it goes around this graph, the slope is changing. But to find the average slope, you just pick the point on the beginning, at the beginning of the interval, at the point at the end of the interval, and you just find the slope using your old-fashioned Algebra 1 slope equation. So the biggest thing is we have to find 2 points. When we were given a graph, we were able to just look at the graph, look at where x equals 1, and then find the height of the function along the y-axis to find the corresponding y value, and then you'd have a point. You do the same thing with this other side, and you'd have 2 points. Then you just use the slope equation. However, when we are given a function, it's not as easy as that. To find these, we still have to find the 2 points, but to find these 2 points, what we have to do is we have to plug in the given x value at the end. It's important we use the x value at the beginning of the interval and the x value at the end of the interval. So we see that it's just like average rate of change over the entire interval. So we need to find the height of the function. Instead of looking at the graph and looking at the vertical axis and seeing how high it is, we have to plug that number into the function and then it's more accurate that way to actually calculate what the y value is given a certain x value. So what I'm going to do is I'm going to do 2 problems of I'm just going to evaluate the function for x equals -4. That's going to give me my first point here. And then the -4, I already know the -4 is the x coordinate, but then the result that I get when I plug in -4 to the function, that's going to be the y coordinate here. And then I'm going to do the same thing. I'm going to plug in +4 and evaluate the function at +4, and that's going to give me, so this is going to be +4, and then whatever I get after plugging in the 4 to the function, that's going to be my y coordinate right here. Okay, so we just have to plug in and evaluate the function for -4 and +4, and we're going to have our 2 points. So I'll write that out for you. Call it an endpoint of that interval. Okay. So I like to, whenever I'm substituting in, I like to write the whole function out. I think the mistakes here, there's a lot of mistakes to be made with these calculations. And I think sometimes a lot of kids, they do the algebra correctly and they understand the process, but they're making arithmetic errors. And unless you know your multiplication, your division, your subtraction, like super well, like I would double check everything in your calculator. Because we're going to do, when we do algebra, we do maybe 30 small arithmetic calculations in one problem. And if you don't get every single one absolutely right on the money, then you're going to get the problem wrong. And you'll be like, what am I doing wrong? When maybe the steps algebraically are not wrong, but your arithmetic went wrong somewhere. So be aware of that. Okay. So we're plugging in x equals -4. So I'm going to rewrite. I'm going to kind of ignore this side, but we're going to rewrite replacing, and I always plug in parentheses, but I replace the x with the -4. Common mistake students make is they just multiply. I think they're just trying to save time or something. And they just, what you can do is to find that on your calculator, you can do -4. You should probably do it in parentheses though. Parenthesis, -4, parenthesis, and then use the little caret symbol in your calculator, even in your cell phone calculator has that, to the third, and that'll calculate that for you. So, but I would even go further. I don't know if I would trust it because maybe you're not putting the right notation in and you might get the wrong answer. So you would just know that we're multiplying 3 of these -4s together. So our answer should be negative. But I'm just using my calculator here and I get -64. So it did correctly do that. So here I have the 6 on the outside and I have -64. And I'm just going to take care of all of these exponents because I know that there's errors made with the exponents, so I'm extra careful myself when I'm doing these exponents. So I'm just going to get rid of them, but they are, according to order of operations, we would do them first anyways. Technically, these two expressions, like this one and this one, I know I'm going to do everything here and then do everything here, like all the division, multiplication and all that, and then add these two answers together. So I could kind of do everything with this one and get one digit if I wanted to, and do everything with that, second. Or I could go through it order of operations wise and do everything that's exponents, But so there's a few different correct ways to do that one actually. Okay, so -4 to the 4th. I know that's 4 -4s that I'm multiplying together, so I should get a positive answer, but I can put it in my calculator, -4. I just never take the time to put it in my calculator. And I don't trust my calculator sometimes correctly. It's 256. And that's another thing that with students I am rewriting as I calculate something, like I -4 to the 3rd power. I'm very organized and I'm very tediously writing out everything that I am doing. So I wrote out -4 to the 3rd. That's -64. People try to keep it all in track in their mind, and then they have all these numbers written everywhere all over their paper, and there's a reason why that we have the style that we have it in this method of rewriting everything a line below so that we don't forget steps and we don't make mistakes. The more we kind of write things out, the less often we make mistakes, I find. Okay, so then now we can do, there's division and multiplication to do, and the addition is going to be last, but 6 times by 64 is 384. So it's a positive times negative, so it's going to be a -384. And then let's see, I wonder if 5 goes into 5 divided by 256. 5 divided by 256. I knew that wasn't going to go in because it didn't end in 5 or 0, but wow, that's like 0.0195. So like really not a very pretty expression. Ouch. That's really not fun to have that one, but that's okay. Okay, and then so this is a positive and that's negative, and I have to remember that I'm actually going to subtract those. So be careful because on your calculator, when you're using cell phone calculators, you have to press enter and kind of get an answer and then do your next thing, because sometimes it'll change and it'll want to do order of operations. So it's just a little bit weird. Okay, so -383.98. There's the answer that I'm getting when I plug. Okay, so when I plugged -4 into the equation, then it simplified to be this number -383.98. So that is our point, -4, -38398. Okay, so right now, this is where we are in this problem. We now have this first point. Now we have to go find the second point. We're going to do that by plugging in the end point, the other end of the interval, which is this +4. So okay. And here's a big thing. I remember as a student, I'd say, oh, look, one's negative and one's positive. Isn't the answer going to be the same? You know, so you can't do, you know, because I know it's a lot of work to sit here and do this. You can't make assumptions like that because a lot of the times it's not the same. And you try to make shortcuts and sometimes it just blows up in your face. Okay, so then x equals 4 is the other endpoint. So I just plug in 4. I can take a shortcut here though, that we saw up here that -4 to the third was 64, or -64. So +4 to the third is going to be 64 again, by just positive. And I can see that this is still going to be 256. Because whether I take -4 and multiply it by itself 4 times or +4, it's still going to be the same answer. And then this is going to multiply out to be the same number, 384, but positive. And it's just going to be +5/226. So that's 384 point, I'll say 0.195. Sometimes we want, if you say be accurate to 2 decimal places, it's pretty good if you are accurate to at least 4 decimal places. In the final answer, if they want you to be, I mean, ideally you would keep all your decimal places and you would not drop anything. These happen to be the same decimal. I mean, and sometimes it's just too hard to do that. So like I at least keep twice as many decimals as possible. So I should have kept 3 decimals, at least. I'm gonna keep, oh wait, 0.0195. Okay, I'm gonna keep 4 up here as well. $9,805. All right. So we have our second point. It is, when we remind ourselves we plugged in x equals 4. So our x value is 4. And the y value is 384.0195. Now we are at this point where we now have the 2 points. All we have to do is find the slope between them. And we do that using the slope formula. So y2 minus y1 all over x2 minus x1. And then x, I'm gonna call this my y, like 0.2. So the y2 is gonna be 384.0195 minus the y1, which is negative 380, I think it was 3 point 383.9805. Okay, and on the bottom, I believe it was 4 is the second point minus a -4. So in the top, we have a traffic jam negatives, and that just becomes positive. So it just becomes addition 384.0195 plus 383.9805 equals 768. All over 4 plus 4, which is 8. Let's see if it divides by 8. Oh, wait. Which it does, it's 96. So our slope, our rate of change is 96. There we go. We can just double check our answer. And that's correct. All right. Let me know if you guys have any questions. Have a good day. Bye.